All right. 3.2, ratios and proportions. All right, a ratio. We've got a few notes today. Ratio is a comparison of two numbers by division and is often expressed as a fraction. An example would be teachers to students. Also can be written teachers to students. All right, I'll let y'all catch up. If you can't see, you can move up closer. Okay, rate. Look, that says rat. Okay, rate. Sorry. It's Monday. All right, rate is a ratio comparing numbers with different units. Example, feet to yards, or hours to seconds. And then unit rate trying to find another way of writing this. is a rate in which the book says the denominator is 1. That makes 0 sense. It will when we start doing examples. But for most unit rates, looking for, and I'll explain this, for 1. And I'll explain this in the examples, looking for 1. I don't know how to explain this. Like, an example would be 85 points scored in 5 games. Well, how many points were scored in 1 game? Or bingo, $370 for 40 hours of work. How much for 1 hour? See, they're looking for that, looking for 1, basically. Okay? What they have in the book, I'm not real, but that's what you're doing. You're looking for 1. Okay. Let's see, do I have room? I'll squeeze it in there. Okay. Everyone ready? Okay, so I'm going to give examples of, ratio first. That says ratio. That's terrible, but it says ratio. Example, and I'm going to squeeze this in down here at the bottom. A school of 312 students, and y'all did this last year, has 168 girls and 20 teachers. Apparently in this example, boys don't exist. But could you figure out how many boys?
Yes. Yes.
Yes, what's correct. If they tell you that the school has 312 students, and it says 168 girls, all you'd have to do is subtract 168 from the total students. That tells you how many boys are in there. Okay, let's say A, they want to know the ratio of girls to students. Emily, how many girls are there?
160.
How many total students are there, Emily?
112.
Now you just reduce. And to save on time, it reduces, I'm going to write reduce, it reduces to 7/13. There's your answer. That's ratio.
So 7 out of every 13 students are girls.
Yep, exactly.
Oh, okay.
Do you remember this from last year?
Yep.
Kind of.
Here, boys to students. It doesn't tell you boys up here, but we talked about how you can figure it out. Raise your hand and tell me how many boys. Aiden?
Oh, I haven't done it.
Well, okay. So, total number of students minus the girls gives you the boys. What'd you got?
144.
Yep. 144 boys out of 312 students. Now, you would reduce, and to save on time, I'm just going to tell you that would be 6/13.
6 out of every 13
Yep.
students.
Now, Raise your hand if you remember another way of writing this instead of fraction. Gabby? 6 to 13. Is there another way, Michael?
6 colon.
13. 6:13. Good job. Hopefully this is kind of coming back to you. Everyone have it down? Taylor, you have it down? All right. Now I'm going to give you a big old example of rate. And look at something real quick. Okay. Rate and one example of unit rate, they're very similar. Yeah. Okay. Unit rate and rate are very similar. So here's an example. With rate and unit rate, whoops, a lot of times you're doing a lot of converting. Okay? This is the stuff that a lot of kids are like, oh my gosh, I hate this stuff. It's going to get even more crazier with the other example. All right, so A. This is an example. Let's say 28 feet, 2 yards. Now, in your book, I believe in the back somewhere there's a conversion chart. For the most part, the examples that I'm going to give you on quizzes and tests and stuff are going to be basic knowledge information. I'm not going to try to scare you on that, okay? But we're going from feet to yards. So this is how you would write it. 28 feet over 1 times, who remembers where feet needs to go, Taylor? On top or bottom? Y'all remember from last year?
Top.
Okay, width,
Right, top.
Gabby?
Oh.
Bottom. Because, remember diagonal?
I don't remember that.
Oh, yeah, I remember this 3 feet.
Okay, so our goal is to go from feet to yards. We have to cancel the feet out. We're changing it to yards. To cancel it, it has to be diagonal. So, how many feet are in 1 yard?
3.
So 3 feet are in 1 yard. They are diagonal. So these feet cancel out. Now I'm left with yards. We multiply across. 28 times 1 is 28. 1 times 3 is 3. You do divide here, and you get 9.3 yards. I want you to write that, sit back, and try to remember to be able to cancel a label or unit out, we have to have it diagonal. Allie has actually used this method through high school and everything, so it is important to remember. Star. be sure that the quantity with the unit to be canceled is diagonal from original. In this case, it's in the denominator, but we're going to be doing examples where it could be top, bottom, everywhere. So make sure that the quantity with the unit to be canceled is diagonal. The only way to cancel a unit, move from one to another, is to have it diagonal. Any questions so far? You got it, Cecilia?
What's the last one?
Original. B. Here's another example. 62 inches, 2 centimeters. What are we trying to cancel, Emily? Which unit are we wanting to cancel? Like get rid of? Well, we're trying to change this to what? That's right. We want to get rid of the inches because we want to change it to centimeters. That's our goal. We want to change it to centimeters. That's our goal. So, I'm going to write 62 inches over what, everyone? 1. Do I put an equal sign here or what? Anyone? Multiplication. Emily, if I'm wanting to cancel inches, do I put the other inches on top or bottom? That's right. Because we want it diagonal so we can cancel it. So centimeters will go on top. So, raise your hand if you can tell me how many inches are a centimeter or how many centimeters are in an inch. Is it 1 centimeter? Which is smaller? Centimeters. So, would we be looking for how many inches are in a centimeter or how many centimeters are in an inch?
How many centimeters are in an inch?
So 1 inch, the 1 this time goes on the bottom. So whatever's the biggest is going to go on the bottom. Look right here. We had yards with the 1 because it's larger. 3 feet go into 1 yard. So we're looking for how many centimeters are in 1 inch. Does anyone know?
Can I guess?
Go ahead.
4?
2.54 centimeters. I'm not going to give you a test question like that. I'm like 3 feet equals 1 yard. Y'all should know that. This, So the inches cancel because they're diagonal. And now I'm left with centimeters. We multiply across. Raise your hand if you can figure out 62 times 2.54. Well, you're going to have to on your homework, so you might as well try to figure it out right now. Gabby? 157.48 centimeters. Very good. Any questions? These you're going to have to think about. Like really, really think about. You got to first, you got to know your conversions. And then you got to remember, does feet go on the bottom? Does it go on top? So you can cancel out, and you got to know your conversions. Which is the one, which is not. That's going to be challenging. Y'all ready for another? All right, here we go. 17,000 miles per hour.
Wow.
2 feet per second. Ah, yeah.
You'd probably die if you were doing 17 miles an hour. Not from collision, from the G-force.
Okay, so Emily, I'll pick you on you again. What are we canceling? What units are we canceling? What do we want to get rid of? That's right. We want to get rid of the miles and the hour. We need to change the miles to feet, and we need to change the hour to seconds. So we've got multiple conversions going on. So we want to get rid of the miles and hours, and we're changing miles to feet and hours to second. You're going to write the rate as a unit rate. Let me show you how to do that. It's the same thing as up here, but we're going to add to it. So write that down. We're going to get rid of miles first. Watch what I do. So up here I have 17,000 miles for 1 hour. Because that's what per means, right? So 17,000 miles per 1 hour. Does everyone see what I wrote? Look at it. 17,000 miles per hour. That means for 1 hour. So I have it written as a unit rate. 17,000 miles over 1 hour. Does everyone understand how I wrote that down? Make sure your notes are good. Okay, now we're going to get rid of miles and hours, but we can only do one at a time. So let's start with miles. So Cecilia, I'm getting rid of the miles. I'm changing it to feet. Do I put miles on top or bottom? That's right. So feet going to go on top. We got to be able to cancel. So 1 mile equals how many feet? Raise your hand. What?
5,280.
Yep. That's 5,280 feet. So now we've canceled our miles and we've got our feet. But we still have our hours. Before I move on, does everyone understand how we did this part to go from miles to feet? Y'all understand that? Okay, I'm going to do another multiplication in bar. So I'm looking to get rid of hours. Michael, where will I put hours now? On top or bottom?
Top.
Why on top this time?
Because it has to be diagonal to the other one.
That's right. Do y'all see that? It's got to be diagonal to be canceled. So since hours was on the bottom, we got to put it on top. Very good. Now, what can I put down here?
Seconds.
You can. Can you also put minutes? Huh? You can. It depends on you, the person. So which do y'all want to do?
Seconds.
Because we're changing it to seconds. So 1 hour equals how many seconds?
Oh wait.
I know how many seconds are in a day.
That's not going to be helpful. So there's 60 seconds per minute, right? So I'll let y'all try to figure that out. 3,600 seconds. And she got that because in 1 hour there's 60 minutes. And in 1 minute there's 60 seconds.
I was gonna divide how many seconds in a day by 24.
So now we can cancel our hours and we're left with seconds and feet and we multiply across. And I'm running out of room here. So 17,000 times 5,280, and yes, I'll let y'all use your calculators, times 1, and I'll just go ahead and tell you to save on time. 89,760,000 over 1 times 1 times 3,600 is 3,600. Do we leave it like that?
We have to reduce.
Or divide? Remember, we divide. And we get, I'll just go ahead and tell you, 25,000 feet per second.
You wouldn't survive that.
Well, who said it's a car?
Who wouldn't survive that in general?
What if it's a spaceship?
I'm still pretty sure it's.
Wait, don't spaceships go that fast?
No,
Oh.
I
They
have
go
no
like-
idea.
they go like 25,000 miles per hour, not feet per second. We'd have to be in. I'm
All right.
pretty sure that's faster.
Are there any questions about this?
No.
Does everyone have it down? All right. These conversions, a lot of people do not like. A lot of people do not like. They're confusing.
I'm not fond of them, but
Unfortunately, you will be seeing them. Okay, now. Proportions. Y'all probably gonna be like, yes, I can deal with proportions.
I sharpen my pencil.
Sure. Proportion is a statement of equality between two ratios. Now, proportions you will see a lot of. So guess what I would say the majority, not all, but the majority of your questions are going to be on like quizzes and tests.
A proportion.
Because you're going to see this a lot. Conversions, yep, I'm going to have them on there. Proportions, more so. Let's say I have 7 over 8 equals x over 4. Right, raise your hand if you don't even know the question I'm asking. Raise your hand if you can remember how to solve for x. Gabby. Cross multiply. That's it. You are cross multiplying with proportions. When you have two fractions with an equal sign, you are cross multiplying. This stuff is a little bit easier than all the other stuff. And let me ask you, Cecilia, when I cross multiply, do I go up or down? Do I go up or do I go down? We always go up. We always go up. 8 times x is what, Michaela?
8x.
And 4 times 7 is what, Michaela?
28.
So 28 and 8x on that side. You will rewrite it exactly how it's done. Don't put 28 over here and 8x over there. You will get a wrong answer. Now you do intruder alert. Divide by 8 and you get 3.5 equals x. Any question about proportions? Yes, Aiden.
You can live in a fraction.
They don't like you to. So in this case, no.
They will hate you if you do it.
All right. Any questions? Let's do another. Solve the proportion. Now I want y'all to pay very close attention to this example. I have similar problems on tests and quizzes. Majority of my students get them wrong. And I'm like, we did an example like this. We've done homework like this. So pay very close attention. X plus 9 divided by 5 equals x plus 15 divided by 7. Just because there's a lot of stuff up there on the top doesn't mean you can't solve this as a proportion as well. Now, could you do intruder alert and still get the same answer? Yeah. So on your test and quiz, when you have a problem like this, there's 2 ways of doing it. Intruder alert or cross multiply. Now look here, guys. You're doing 7 times this whole thing on top. So that's 7 times x plus 9. And then 5 times that whole thing on top. This is where my students get confused. You're multiplying that 7 by everything up here, so that's called,
Distributive.
and you're multiplying the 5 by everything, and that's distributive. 7 times x is?
6.
7 times 9 is?
63.
5 times x?
5x.
And 5 times 15.
45. No.
75.
Now we can do intruder alert. Let's see. Emily, what would I move over? Okay, and how do we do that? Very good. So I have 7x equals 5x plus, what do I have, Emily? Now, Cecilia, what do I do? Very good. Subtract 5x from both sides. You get 2x equals 12. Now what do I do, Michael?
You divide both sides by 2.
And you get x equals 6. Any questions? Y'all have this down?
I don't know how to say yes in Russian, but yes.
Any questions? Proportions, I think those are gonna be y'all's friends. Yes, Aiden?
Are we gonna the work today or not?
Well, I don't know. Alright. I wouldn't worry about that right now.
Or else she is gonna have.
Alright. A car traveled 250 miles on 9 gallons of gas. That's not too bad, actually. How many gallons are needed? Are you writing this down? To travel 360 miles. Okay, so real world kind of problems. A car traveled 250 miles on 9 gallons of gas. How many gallons are needed to travel 360 miles? So, write that down. This is done as a proportion. Again. Alright, so we have 250 miles. Watch how I set this up. 250 miles for 9 gallons of gas. And they want to know, and you'll see these kind of problems a lot. How many gallons are needed to travel 360 miles? This, I've always questioned why they have proportions in with units, rates and unit rates, because the rules are different. In this case, we're not canceling anything out. So when doing proportions, miles is not going to go on the bottom. We're doing proportions. That's why I want focus more on proportions. You do that a whole lot more. So we know they're asking for miles. We're going to put it on top. They're wanting to know how many gallons. So gallons are going to go down here. So look at this again. A car traveled 250 miles on 9 gallons of gas. How many gallons are needed? We can even say gallons right here. To travel 360 miles. Yes, Whit.
Will it always be on the top?
Normally, yes. Yes.
Will we see one where it's on the bottom?
I don't know.
No.
That's what I'm saying. 9 times out of 10, when we're doing this kind of stuff, it's going to be set up just like this. 250 miles on 9 gallons. And then you always keep the labels together for proportions. So again, we cross multiply. 250 to, and again, Cecilia, do we go up or down? Up. So x times 250 is 250x. And 9 times 360 is 3,240. I always circle these so I can remember. And then I rewrite it and keeping it on the same side as it was done. And then we do intruder alert. Divide both sides by 250. And we get x equals 12.96, real world, about 13 gallons.
Would you give a room for keeping it as 12.96?
No. I mean, unless they tell you to round to their whole number, I'm not going to. If you can get to this point, you know how to set it up, I'm happy. And in fact, like if you were to take the PSAT, they're not going to give you a choice of 12.96 or 13. That's pretty much the same thing. You know what I'm saying? Unless they say round and nearest whole number and this was one of your choices. And they try to trick you that way. But yeah, no, that's the same thing. In real world, when we're dealing money and gallons of gas and stuff like that, you just kind of round. So approximately 13 gallons. Now remember, in proportions, keep same units on top or together. That really makes no sense. On bottom.
What?
In proportions, here, I'll rewrite it. In proportions, yeah, keep units on the top together, keep same units on the top or together on the bottom. You want to keep the units on the same side. Keep units together. Either top or bottom. You can write it in your own words. So in proportions, because remember when we're converting, we wanted to do diagonal because we're canceling, right? Well, in this case, we want to keep the units together. Like we had gallons and gallons, miles and miles. We want to keep the units together. You understand? Any questions so far? Okay, write that down. Take out, make sure your book is open, or get your book out and turn to page 101. I do not see y'all doing independent work today. There is not enough time. I don't want to rush the examples either. I want y'all to have as many examples. Ask questions, okay? If you're like, yeah, this is ugly, but I get what she's doing, okay. But if you're like, where did y'all get that? What does that mean? You need to ask. Does everyone have this? So do you have it? Got it? All right. So we are doing examples, page 101, 102. So I'll probably move your quiz to Friday.
Yeah.
All right. Number 1. Let's see. Aiden, read the directions.
I researched students received today. 10 received a B, 6 received a C, and there were no D's or F's. Write the following ratio, the lowest ratio.
Okay, there's a lot of information now. With this stuff, your information a lot is going to come from the directions. So if you need to highlight or underline the stuff in the directions that's important, you need to do that. The last thing says write the following ratios in lowest terms using the word to. That's also important. So number 1, they want to know the ratio of A's to B's. They want to know the ratio. Ratio is your clue. It's going to be a fraction. Ratio of A's to B's. So Aiden, How many A's did it say?
8.
It's going to go on top. A's to B's. That's how you know what goes on top. The first thing listed goes on top. The last thing listed goes on the bottom. So how many B's, Aiden?
10.
All right, now it says put it in lowest terms. So if you reduced it, what would you get, Aiden?
4 over 5.
And they also said to write it using the word to. So it'd be 4, 2, 5. If they didn't tell you to use the word to, you could leave it as a fraction. To be straight up, if you guys gave me this, I probably wouldn't count it wrong. If you gave me this, I probably wouldn't count it wrong because you know what you're doing, but let's try to follow directions. Any questions about that? Oh, everyone understands. 3. This time they want the ratio. So Michaela, it's going to look like what since they say ratio?
Fraction.
Very good, a fraction. Of A's to students. Okay, so here's my fraction. So, Michaela, what goes on top? What's the first thing they ask for? Ratios of A's to students. So what goes on top? 8. Very good. So remember, guys, when whatever is listed first, typically what goes on top. Now it says to students, total students. So you actually have to add up everything in the direction. So how many total?
24.
Very good. Does everyone see where she got 24? In the directions it talks about how many kids made A's and B's and such, she added them up and she got 24. Now reduce it.
Divide by 8.
Yeah, you can divide both sides by 8. And what do you get?
1 over 3.
1 over 3. And we write it 1, 2, 3. Any questions?
Just run 1, 2, 3.
I didn't even catch that. 1, 2, 3.
Math fun.
All right.
You're so kind, Taylor.
Any questions about 1 and 3?
2.
All right, let's do 5. Michael, read the directions.
Find the unit rate.
Very good. They're telling you we're doing unit rate. Now remember what I said with unit rate, you're basically trying to find the one thing. So for 5, it says, that's the example I gave you in fact, 85 points scored in 5 games. They're looking for how many points in one game. There's that one I was telling you about. And all they're going to say is 85 points scored in 5 games. And you're going to literally sit there and say, well, what do they want us to do? It's unit rate, so they're looking for how many in one game. So we set it up as a what, Michael?
Fraction.
And what goes on top?
Points.
Points. So 85 points in 5 games. So 5 goes on the bottom because we're looking for how many points in one game. 85 divided by 5 is what, Michael? So 17 points per game. That's where that 1 comes from, and the definitions where it says is a unit rate is a rate in which the denominator is 1 or you're looking for 1. That's what they're talking about. 85 points scored in 5 games. How many points in 1 game? Yes, Cecilia.
Would you get wrong and put 17 over 5?
Yes.
I mean, upper one.
No.
Okay.
But that's the same thing as this, right? Yeah. So they're looking for, they're 85 points in 5 games. How many points in 1 game? Let's look at 7. $370 for 40 hours of work.
This is the other example you gave.
Yep. So you're looking for how much for 1 hour of work. So we're looking for how much for 1 hour of work. Gabby, after you write that down, tell me how to set it up. That's right. So 370 on the top, 40 hours on the bottom. And then Gabby, you work out and tell me how much for 1 hour. Perfect. $9.25 for 1 hour per hour. Good. This is good. Like, for example, my job. We don't get paid by the hour. We get paid, like every 2 weeks. Okay? So we're supposed to work a 40-hour week. So what we have done many times is taken our salary and figured out how much we're making per hour. So when you go into the business world, they may offer you a salary and it may look really good. Divide it up into how much you're making per hour, and that may tell you whether you want to accept that salary or say, yeah, I'm below the minimum wage. I think I need to find a job. It looks good when they put it all together, but when you break it down per hour, it's sometimes shocking. Do you see what I'm saying? Don't just accept a salary because it looks good. Divide it up per hour so you know how much you are actually making. If you're working really hard every single hour and you're making $5 an hour, don't know about that. See what I'm saying? You want to make sure you're making the money. All right, we're going to stop there, and then we'll continue this tomorrow.